All right, guys, we're going to get into determinants and areas of polygons. Problem number 2. All right, so this is the formula that we're going to be using for all of these things. My best advice for you is to write everything down on a graph first. So create a visual aid, because if you try to do this without that, you will be lost and it's going to be really weird. And you're going to get frustrated and you're going to want to quit. So don't do that, because there are much easier, much less stressful pathways to follow. And the easiest pathway is to just write it out, guys. Just write it out. So let's see here. So here I'm going to go by 2. So 2, 4, 6, 8, 10, 12. And then right here, since we go from 1 out to 10, so I will do 2, 4, 6, 8, 10. Right. All right. So what are our points here? Well, we have 3, 2, 10, 12, 1, 9, and 8, 3. 1, 2, 4, 6, 8, 10. So 1, 9, and 8, 3. There we go. So once again, if you're thinking back to the geometry and algebra 1 work, right? So if you're looking at a polygon and we're thinking about, because in the context of algebra 1 and geometry, you're trying to figure out how many degrees are in the interior of a polygon. So you break it up into triangles, because a triangle has 180 degrees, and you figure out how many triangles there are, so that number times 180. So that's the context that you learned this in algebra 1 and geometry. So right here, I don't know, which way do you want to do this? I kind of want to do, let's do this. You could also, obviously you could, if you wanted to, you could cut it this way. That's fine, whatever. The idea is that we have 4 vertices, so 4 minus 2 means we have 2 triangles that we're going to create. All right, so blue is going to be triangle 1, red's going to be triangle 2. Right, we've done this before, so you guys should start to feel pretty solid with this. All right, so triangle 2, we have 3, 2. We have 8, 3. And we have 1, 9. For triangle 1, we have 1, 9, 10, 12. And we have 8, 3. All right. So let's get the determinant for what we're calling x, right? Because that's what this thing is right here. So this big X, this capital X that you see, is really, it's the matrix that we just created, right? So that matrix for triangle 1 is going to look like 1, 9, 1, 8, 3, 1, 10, 12, 1. So we say now, okay, we've created the matrix. Now, since I want the determinant, and by the way, you can put this into your calculator, right? So you can create a 3, so 1, 2, 3 rows by 3 columns. You can create a 3 by 3 matrix and have the calculator calculate this for you, but it's easy enough to do this out by hand. You just repeat the first 2 columns, and we do some multiplication diagonally from left to right. So 1 times 3 times 1, all right, plus 9 times 1 times 10, plus 1 times 8 times 12. So we're getting into some larger numbers here, right? So that's 8 times 12 was at 96, so 189. And from that, we're going to take away going from right to left. So we have 9 times 8 times 1, plus 1 times 1 times 12, plus 1 times 3 times 10, right? We're just going diagonally from right to left. So that is 72, 12, and 30. So 70 and 30, so 110, 114. So 189 minus 114, that is going to be 75. So our area is 1/2 times the absolute value of 75, which is 75 halves. So 75 halves is 37.5. All right, and we're talking about units since we're talking about the area. It's going to be square units. All right, so now we need to do this for triangle 2 as well. So triangle 2. So we know that that third column is all ones. So we have 3, 2, 8, 3, and 1, 9. 3, 2, 8, 3, 1, 9. All right. Let's go ahead and let's erase these borders and rewrite the first 2 columns. So now let's go across from left to right. So 3 times 3 times 1 is 9. 2 times 1 times 1. And 1 times 8 times 9, 72. So 79, 81, 83. Minus, and we're going to go from right to left. So 2 times 8 times 1 is 16. 3 times 1 times 9 is 27. And then 1 times 3 times 1 is 3. So that's 20, 37, 40, 46. So 83 minus 46 gives us 37. Our area is 1/2 times the absolute value of 37. So 37 halves, or 18.5. All right, so our polygon right here, so the area of our polygon, 37.5 square units plus 18.5 square units, so 48, 55, 56 square units. So I didn't emphasize that heavily on the example problem, but it's something I want to emphasize now on 2, 3, 4, and 5. Now that you're getting familiar with this, make sure that you remember units, because you always want to be able to do dimensional analysis in math. So it's important that you don't think, well, 56 what? 56 pizzas, 56 rolls of paper towels and toilet paper, 56 tires, 56 Xbox Ones, 56 square inches. What is this? It's square units. So give the units so that if we needed to, we could do a dimensional analysis. It's problem 2. It's going to be the next video that I'm posting. And to follow this will be 3, 4, and 5.